Друзья, добрый день. Просим прощения за небольшую задержку. Сегодня у нас квартирник, посвященный полиглотному хранению данных, полиглотным базам данных или решениям, которые могут применять эти полиглотные базы данных и проектирование таких решений. Прошу приветствовать Дина Эспозито и Михаила Яричук.
Frankly, the first time that I heard polyglot persistence as two words, one close to the other, I thought, oh, that's nice. Sounds good. Polyglot persistence. Then I said, well, who's the idea to invent it? Put the two things together. Polyglot persistence. We have persistence. So, I mean, the idea that persistence could be done in different ways was essentially nothing new to me. But just I would have used other terms to express the same idea. I would have just called it having a layer of repositories around data, around physical data. And just because I would have used the expression repositories, that meant to me that, okay, it's a way that encapsulates what really happens when we physically save data. Because actually, the way in which we save data is a detail compared to the way in which we make data interacting with the upper layers of the application. So once I have in facade, in a repository, in a wrapper, a common programming interface for reading and writing, the detail that I write to a SQL Server table, that I write to an Oracle, that I write to an Azure table, or an XML file, is absolutely transparent. However, what I missed is that what the term polyglot persistence actually want to indicate, or the most relevant aspect of it, is something slightly different and subtler. Polyglot persistence is, in normal term, a polyglot indicates a person who can speak multiple languages. What was my original intended meaning for polyglot persistence was, okay, the same as you have a repository that hides the detail of what you persist and how you persist it. But in my vision, the repository layer was just one of many possible ways of persisting data. Polyglot is different, is storing data using a variety of different mechanisms at the same time. It's kind of a orthogonal thing. It's not choosing one of many, but having multiple persistence mechanisms working together in the context of the same application, and then possibly underneath a repository layer. So, why is relevant? What makes particularly relevant the fact that we have today available, and should consider polyglot persistence? Because it's an architectural concern. And it strictly relates to some of the things that I discussed yesterday in the keynote as one of the challenges of modern software development. We typically write software following a procedure, a step-by-step procedure like here. We first try to make sense of user requirements, then we build. This is what we do today, right? We build a data model out of what we have understood. So we form an idea, and because we are experts, architects and developers, it's natural to come from, as we understand, as we make sense of what users are asking for us to build, we sort of imagine in which way the data underneath the business domain can be effectively persisted. And when we do this, 99% of the time, we think of relational models. But it's not our fault, or it's neither our fault nor fault of the relational model. It's the way in which we grew up, the way in which we've been educated. When we went to university, everybody all over the world, we received strong skills about relational, and anyway, we've been bombarded with information of the relational model, with all the various normal forms, fighting redundancy, looking into foreign key relationships, constraints, cascading updates and deletions. All those things are part of our being professionals today. So it's natural now that as we envision a system, we envision the system because we already have developing in our mind a relational model, a model which is relational. And this is limiting for two reasons. Because it's relational, okay, first, because it's a data model. And second, because it's a relational data model. But not because there's nothing wrong with the relational in itself. It's that it's limiting. We might be losing information if we only blindly commit to just relational models. I mean, it's already a blame that we focus on a data model such at an early step of the design process. But if we do that and we stick only to relational, this is even worse. Okay, after that, step number 3, we identify relevant tasks, relevant data tables in the previously built or envisioned relational model. We then finally build a user interface which is more or less close to what users wanted. And when we deliver, finally, proud of our efforts, the software, we found out that users say, well, this is close what we wanted, but it's not exactly what we meant, and then you try again over and over again. Okay, now, let's see what we can do and in which way we arrive to consider polyglot persistence, which Michael then will hopefully Michael, right? Michael, hopefully you demonstrate. I just try to involve you a little bit more, yeah, come on. Well, I'm boring. When I speak, I'm boring. So I know that you're boring, but you know, don't think of me, okay? Think of polyglot. Anyway, so there are a few weird things: DDD, CQRS, blah 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 blah. The position they are on screen is not, of course, coincidental. But let's see what kind of graphics I'm going to build to give sense to those words in the position they are. Each of these terms, domain-driven design, CQRS, event sourcing, relational, NoSQL, they are buzzwords. And sometimes we are able to use those buzzwords in the right context properly. Honestly, most of the time we just use those buzzwords. Sometimes we even use those buzzwords as we speak rightly. But I challenge everyone here, and even myself, to have a full vision of the things, how they relate together. So let's try to see in which way they can be related together. I would say domain-driven design can be an island in the sea of software development. CQRS and event sourcing and relational and NoSQL can be grouped together. And the idea now is that we have 3 islands, each of which contains a few, one or more buzzwords that all by themselves mean essentially nothing, but united with others, they start getting more sense. So CQRS goes with event sourcing, but goes with is not necessarily it has to go with, it must go with. It means more it can go with. So CQRS and event sourcing can go together in much the same way in which relational and NoSQL data stores can go together. And the three islands we have identified on screen, one, domain-driven design, identifies the analysis stage. And expanding DDD, we see that it's all about the domain, it's all about analyzing the domain, understanding the domain, and in more concrete terms, it expresses itself in terms of a ubiquitous language and bounded context, which are the pillars of the fundamental patterns of domain-driven design, as far as the analysis is concerned, which is the most relevant and part that you should always consider regardless of what you do after next when it comes to implementation. So we have analysis. CQRS and event sourcing can be expanded in a number of possible concrete architectures, some of which, or the most relevant of which I covered in the session before lunch. And we are in the realm of design and implementation. So we have a CQRS, so the simple basic split of command and query stacks, which can go with or without a domain model, so an object-oriented implementation of the business layer according to the domain model pattern. It can go with or without event sourcing. So even sourcing, it's nice, because event sourcing is, at the end of the day, just a fancy name, modern name, for something, for things that developers have been doing since the very early days of software engineering. I mean, today, if you Google, and open a parenthesis, little anecdote. When I gave a couple of talks at Microsoft TechEd in Barcelona, October, it's Microsoft, right? So, the first day, I had a full day workshop, and as I always do, I say, if you Google for, yeah, I mean, I got a feedback. Look, you have 2 more talks. If you could avoid saying, if you Google for, if you cannot find, another, say, if you Bing for. Okay? So, whether you Google or you Bing for. And I say, well, I say, but, I mean, I don't know exactly what Bing is going to return. I know what Google returns when I make some certain queries. I have no idea what Bing may return. Maybe it's not the same. So, if you Google for or Bing for event sourcing, you find that it's all about using events as the data source of your application. So, taken to the limit, it means that you don't have any classic data store, you have no relational databases. All that you have is some database of some type that stores information about events you detect. So instead of having a record with the order that has just been entered into the system, you have, something like a document, an object that describes the event of an order being created. So you find information like a code that identifies the action of creating the event. This code, could be a number, could be a string, or could even simply be the type of the class you are going to persist, order created event class. So let's say you have some information that in some forms identifies the type of the event. Then you have the details of the event itself. So the event is about creating an order. Okay, you have the information about the order. You have the, you have the ID of the order, you have something that identifies the customer. You have something that identifies the items. You have information about the payment methods. You have information about the shipping details. Some other information about notes that the customer. So this is shipping requested to be happen to take place in the 3 days. So blah blah blah. And then you have some timestamp. Now, something about the customer. Suppose that in the real world, if you go physically to a shop and you want to buy something, the good you want is not available, and the vendor, the shopping has to order that for you. What typically happens is that they give you back a piece of paper with the number of the order, the date, and information. So information is expressed freely in a free form, as well. Whereas in a relational model, you have an order ID, you have the customer ID, you have the ID of the shipping company. So a lot of information is inserted in a relational model by reference, through foreign key references to other records in other tables. But in an event, you can have the customer name, or maybe you can have a reference to a customer object, or you can have also the customer ID, but also the customer name. So in an event, you have all the info from the UI, okay, that can be helpful. And it's acceptable that there is a redundancy. So if you have more than just the customer ID, but you also have the last name, it's okay, it's acceptable. Because if you have that, it's assumed that at some point you find that info handy, having that info handy, useful. But even sourcing in the history of software engineering has always existed, with no name, as an unnamed approach. The point of events is tracking the entire lifetime of a software item. So an order is created, but at some point in its lifetime, an order turns the state into being processed, delivered, or maybe cancelled, or maybe updated. So there might be several events that relate to the same order. If we use a classic relational approach, we only have one record that identifies the order, maybe with an extra column that sets the state, and all that we do is we overwrite the value on the state whenever the state changes. So we are able at any time to understand, to read, to figure out what's the current state of the order, but unless we take some extra effort, we never know when the order was originally created and how it was modified over time. We can add yet another column to say created on a day, last updated on day, but the history, it's hard to track. You can have the starting point, the current point, maybe the end point, but everything that happens in between these three fundamental states is lost, or risks to be lost. If this is critical for the business, you invent some other table where you store something, maybe some relational table where you store something that relates to the changes. And then you have to rebuild the state. Event sourcing is about streamlining, simplifying these kind of things. And look, in banking and in many other, even in several industry types of software, it's common. It's always been happened that we track events and the history of things. So it's nothing new, event sourcing. The name is nice, and there is the new flavor that we can consider events to be the source, the only unique data source of the application, which poses immediately a number of other issues. Because we can say, okay, if events are the data source, how can I rebuild and materialize objects? So how can I rebuild the final effect of running all these events? How can I replay all events up to building the current state of the object? And okay, replaying events, starts, raising a number of issues. Is doable, but it's not that obvious how you do. I mean, it's relatively easy to understand how you can do that in one application, but how can this be generalized, put into a framework for any type of event to be replayed? Well, it's not tricky, and actually there is no widely, commonly accepted way of doing this today. But event sourcing is, anyway, a type of approach to development that goes very well together with CQRS, because it takes advantage of the fact that command and query stacks are neatly separated, and you can have events just touch on the command without impacting in any way the other half, the read part of the model. The third island here, relational plus no SQL, becomes the part that relates to persistence, and is essentially persisting data with or without relationals, with or without whatever flavor of no SQL data store we may know. So if we look at the islands, now in general we have analysis, we have design and implementation, we have persistence. So the three key steps of a software project. And what I'm doing now is, in the next few slides, expanding on the structure of this session here, this panel is discussing the three aspects: analysis, design and implementation, and finally persistence, so actual examples of polyglot persistence. But you will see, and that's key, that polyglot persistence is not just a feature we want to have because we want to be cool. We want to astonish friends and colleagues or maybe customers by saying, oh, wow, my application, we do polyglot persistence. And there was a time in which, it was a point for vendors of software to, put out as a part of the advertising campaign the internal technology they were using for building things. The first example of this is Turbo Pascal or Turbo C++. We say this is an object-oriented framework. We build Turbo, we invite you to learn C++ and programming with objects, but the framework itself, Borland, the framework itself is object-oriented. Who cares? Okay, but the second example is when I heard with my own ears Bill Gates, I think it was a some TechEd, saying, well, we are proud as Microsoft, we are proud to announce that blah, 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 this is great, this framework, blah, blah, because it uses XML. It was the time in which XML was all about everything. XML was was a synonym of openness, was a synonym of being cool, and Microsoft at the time was in the age in which they were trying to please the world. They just discovered that there was something called the internet somewhere that Microsoft totally ignored for years, and XML was in a way related to internet, and so Bill Gates wanted to emphasize that, well, just because he uses XML, it has to be really cool. So sometimes I think that, we do know SQL. It sounds, oh, wow, we don't know SQL, so it's cool. The point of is we do know SQL. No SQL is really cool. There was a friend of mine who told me something some 5 or 6 years ago, and it was before NoSQL started getting root. And he said, well, I always wondered, we were eating pizza, so we were totally relaxed. I said, well, I wondering for which fucking reason, in the history of software, object-oriented databases never picked up. So, it's always been proposed, dreamed by developers. Imagine how wonderful life can be if only we could save objects in object-oriented databases instead of going through ORMs, and hibernate, the fucking hibernate. Sorry. No, the even worse entity framework. Okay, NoSQL is, I mean, some flavors of NoSQL is, I mean, to me, looks a lot like object-oriented databases. I have an object, I persist the object. I make a query, I get the object back. But, you know, object-oriented databases is an old-fashioned term. NoSQL, which never, it's not clear if it means not only SQL or just no SQL. I mean, if I talk to relational guys, they say, the last one was last week in London, says, but I don't understand why a technology should pick up negating others. So there's SQL and there's no SQL, and I'm cool because I'm no SQL. No SQL. Probably it's, well, and then to avoid that, others said, no SQL is not only SQL, which makes sense. But whatever it is, no SQL are taking root, and I mean, no SQL is not just object-oriented or document-based stores, but it's a number of flavors of different things that all together are alternative in the way in which they store and retrieve data to classic relational models. And there is a reason. Things never happen by chance. There's always a rationale behind. And rationale behind. There was also a rationale behind the rational rules. Okay, well, that's cute. Okay. At the time, there was a very strong rational. Today, UML what? Anyway, so there is a rationale behind NoSQL stores, and this is, I strongly suspect, this has to do with architectural issues. Again, ubiquitous language again? Yeah, yes, I want to bother you more with ubiquitous language, which is not an artificial language. It's a language natural as possible. It's just the essence of the natural language, of the business, of course, that comes out of interviews and brainstorming sessions you run with customers, and it's iteratively composed and modified and updated and refined along the way, up until it becomes unambiguous and fluent, semi-formal and acceptable for the semantics to domain experts and for the syntax. I mean, syntax means unambiguous, essentially, and composability from the perspective of developers. Meets expectation of domain experts and technical people. But now, Mr. Eric Evans wrote in a blue book about domain-driven design, use the model as the backbone of a language. And then Eric Evans himself, years later, actually, changed the order of elements in this sentence, used the language as the backbone of the software model. The point is not Eric Evans, who is a really smart person, humbly said, well, I probably realized that years later, I realized that I got it wrong, and it changed his mind. So the problem now is that if you Google or Bing or whatever for domain-driven design, you find a lot of posts and alleged experts and gurus that proclaim that they are, no, DDD is what Eric Evans said. Use the model as the backbone of the language. It's written in the blue book. The point is not Eric Evans. The point is Eric Evans and people who work with or closely follow Evans, but is everything else in the world, especially gurus that hold that they've always used SQL Server and Entity Framework and linked to SQL, and all of a sudden turn out to be, oh, I do domain-driven design. And my problem is, how can I make bounded context communicate to each other? My only problem is, How can I create a DB? Oh, yeah, bounded context is having 2 DB context classes on entity framework. Instead of having just one DB context class, I create multiple DB context class, and yeah, I'm doing domain-driven design. So it's great. This is the problem. This is the real problem. And if you Google or Bing, especially if you Bing, I would say at this point, for domain-driven design, you find that this sentence gives you the wrong perspective, okay, of what is the purpose of analysis and why ubiquitous language is so crucial and important. So this sentence has to be reformulated, and note to self, add an animation that when the refresh symbol runs, models and language are swapped. Thank you, Dino. Discovering the ubiquitous language leads to understand the business domain in order to design a model. This is the right way. Any model that works. Not necessarily an object-oriented model. And in fact, real DDD communities, some people in these communities are already experimenting with functional models, so with functional languages. And it's not completely out of place. I got a couple of questions yesterday from people, from attendees, about my opinion about functional models and if they really make sense. It makes sense. I don't know if it's effective or if it can be applied on a wide scale, but it makes sense. It makes sense because when it comes to functional, it's all about tasks. And when it comes to business and when it comes to the real world, it's all about tasks. In the world, in the real world, we don't have and we don't see models. We only see tasks and events. So all the buzzwords, ubiquitous language, even sourcing and UX driven that I mentioned yesterday, they are all going in the direction of giving a lot more focus and importance on events and tasks and processes that we find in the real world, and not just abstract modeling, the God mode of software architect. I feel like God and I create the world with objects, starting from my domain object. Problem space, we have a domain that becomes a domain model. Again, whatever model works for the domain, in the solution space, in the domain we may recognize, abstractly speaking, subdomains, and we match subdomains to bounded contexts. This is the full vision of the analysis part of domain-driven design. So understanding the domain in order to build the model means understanding type and shape of the data being used. And this is the first part of what we have said so far. It means understanding how data, individual pieces of data, can be and should be aggregated together to provide aggregates of data that can be used in the workflows, in the processes. Okay, at the end of each process, typically there is persistence. Persisting, saving the state so that it can be reloaded and we can resume from there. And we persist what? We persist data. And how we persist data? So far, we always persisted data and always aggregated data together to be moved around through the steps of required processes using a relational data model. That was the first thing we built. The point now is ignore what could be an effective data model, focus on tasks and processes and terms. From terms help you understand how to aggregate data, and aggregates of data is how data should be moved through the workflows, and at some point, at the end of some of those workflows, you have to persist data. What is the most effective way to persist the data in the particular model? Okay, it can be that relational is still the best way. And the best way means simply the best way for the project. So there's no way like being religious about these things. Oh, I belong to the relational camp and I want to kill all people who are part of, who trust another God called the NoSQL God. So it's not really a matter of religion here. It's a matter of being effective. So it could be that, all considered, relational is best. I mean, last night I was saying to Michael of an experience that I had with a fairly large customer. The application we were talking about is an application that at some point has to, it receives data from hardware sensors in large quantities, and this data has to be written down somewhere, has to be persisted. It doesn't really matter how it's persisted, as long as it's persisted as soon as it arrives. So the constraint is write, as fast and quickly as possible. And then this data has to be read back. It can be done asynchronously, so it's asynchronously read, aggregated, some key performance indicators are calculated, stored for further processing up until this flow of data ends in a relational table that is made to measure for the UI to consume. They asked me, as an external consultant, to work out a document comparing NoSQL stores, and in particular we focused on document databases, and specifically RavenDB, and relational SQL Server. So my document was, to cut the long story short, was, for sure, RavenDB is perfectly able to manage the traffic and to write effectively. So we can use that. And the benefit of using a document store in that particular case was not just the eventual consistency feature of RavenDB and document databases, which means they are not strictly ACID. So essentially what you write is immediately readable in the form it is. But there could be, even for performance reasons, a slight delay between when you write and when you are ready through the same API to read it back. Which is also, again, the same reason why at some point relationals with too many writes per unit of time start offering bad performance. Because the point is all in the time it takes in updating an index and how the index is close to the data you're writing. So if you find, in terms of performance with the relationals, they offer full ACID support. What you write at the end of the transaction is ready as is for reading. This is not always true. I mean, there is a delay, milliseconds delay, when you use typically, and this is called eventual consistency, with most NoSQL stores, especially document databases. This is exactly the reason that makes so effective these tools when you have a lot of writes to perform. So it depends on what you want. It's a trade-off. It's a clear trade-off. So it's not a bag here or there. It's just a trade-off. So in terms of trade-off, Raven would have been, in that particular case, even better. Also because Raven and document databases, they are schemaless, in the sense that whatever is the object, they can persist it. And they, using the type information, they can relate together elements, pieces of data, forming a sort of a collection which is close to the idea of a table. The problem with SQL Server is, because events, so hardware events, come frequently, but each event can carry different blocks of data, organizing the schemaless data we receive in a schema-full model, in a fixed number of columns, can be tricky. And we calculated that in the particular case, we needed up to 500 columns in SQL Server in order to store the data we were receiving in a relational model. And of course, because of the schemaless thing, 500 columns but in each record, 90% of the columns were just empty, and only a few were filled with waste of space and time. Document databases are perfect in this regard. However, at the end of the day, the chief architect consulted with the IT department, and they decided to go with SQL Server. And they worked out tricks, implementation tricks, to squeeze out of SQL Server every little bit of performance. They also manually decided to implement sharding, which is another great feature that most document databases and NoSQL solutions offer out of the box. In SQL Server, it's possible, but it's you to manipulate over shards the query of data. For a number of reasons, the most prominent of which was that because they had a lot of IT people providing customer care, they felt a lot more comfortable with classic SQL Server than with the tools, or with, they just didn't want to be retrained, or didn't feel comfortable to be retrained. So it was considerations not strictly software related, okay, that brought in that project to use SQL Server instead of documents, even for a scenario where documents were probably the best technical choice. This is to say that how you persist data depends on the data, but depends also on the context, the company context, the project context. And this makes how you persist data an architectural concern. It's no longer an implementation detail. So, Michael, get ready. I was that final slide. Okay, so in summary, understanding the format of the data, that as data is moved, and which is an information that you start getting out of the ubiquitous language, is relevant down the stack up to the point in which you need to persist data. Because if data in the application is made of documents, or can be easily rendered with documents, frankly, I don't see why you should not be storing that data in a store that allows you to treat objects as first-class citizens. Now, you may decide that at the end of the day, you still prefer to go with SQL Server. And it's your point, it's your decision, your responsibility as an architect. But ruling out, not considering polyglot persistence, so SQL with or without NoSQL, it's just a point that you are missing potential information, and you are potentially building a not so accurate or less than ideal solution in architecture for the problem. Okay? Michael.
Привет всем, меня зовут Михаил, и я буду проводить расскажу кое-что на английском, по разным причинам, в основном для того, чтобы было удобно и более эффективно вести совместную панель с Тином. So, I will speak a little bit about how you actually do stuff that works. More about some practical things that you can do. But before that, I'll tell you a little story. I promise you it is related to this discussion panel. It's about World War II. Americans when they were fighting Japanese in the Pacific, they made some bases on several islands, and there were some Indians there. They didn't mess with Indians, everything was okay. Years later, paleontologists and historians came to those islands, and they saw, imagine this picture, airfield built of straw, and each evening, Indians with two lighted sticks doing this. Americans built airfields on those islands, and Indians saw that. They didn't understand what they were doing, but they saw that they did some ritual. Strange people did some ritual, and food dropped from the sky. How nice, they thought. We want to do that also. And those Indians told the paleontologists that they hate Americans. And why? Because they were liars. It was called, they called it cargo cult. Cargo cult, it's everywhere. People do stuff just because people did it before and it works. So I have a solution to all of your problems. Doesn't matter any problem. I have a solution. SQL Server. And that story that Dino told, in my experience, many times, not always, but lots of times, the decision to use SQL Server is just because we used it before. It's enough. It works. We don't need those fancy NoSQL. Why should we use that? It's scary because it's new. Why? I've seen it happen also. I'm sure everyone at a certain point of time met that approach. We're talking here about polyglot persistence. I'm sure most of you at least once heard that term, but what is it about? It's not something concrete. It's fairly amorphous term. It's about understanding. It's about, okay, I will just phrase it with one sentence. It's very simple. You cannot hit nails with microscope. You'll take a hammer, right? Гвозди забивать микроскопом не стоит, правда? So, SQL Server essentially this. You hit nails with a microscope. I'm not talking. I love SQL Server. Don't get me wrong. I love SQL servers. They have lots of uses. They are very useful, mathematically proven to be correct. But they are not always the best tool for the job. Historically speaking, and now NoSQL, I would say movement, because it's very hard to define what is NoSQL database. But by negation, it's practically impossible. NoSQL movement historically grew from one need only, scalability. And one specific type of scalability. There is two types, horizontal and vertical. And you know the vertical one, you just buy bigger server so SQL Server can continue breathing and living. You just throw money at the problem and hope it will solve itself. That's an approach, but people discovered that and I'm talking about companies like Amazon, like Google, they discovered that specifically people's attention span is very short. So they need to squeeze as much speed as possible. And how do you do that? Vertical scalability has another drawback. We have reached limits, physical, hardware, on operational level, operation system level, that system cannot scale anymore under load. What's the solution? Divide and conquer. You just buy 100 cheap servers and you parallelize your work. So what do we do? What do we do with NoSQL databases? There are several types of them. Dino has mentioned one of them, document databases. They essentially your old-fashioned object databases. Graph databases are evolution of that. They also store relations. Neo4j, for example. Very prominent database. Document database, I'm sure you heard at least once. CouchDB, RavenDB, shameless pun. Key value stores, things like, for example, I like Voldemort DB, really nice one. Also, it's distributed. Bigtable, it's really strange beast, and I won't talk too much about that because I never used it. But it also exists. So the biggest question is, how do you make it work? Data has many shapes. Data has many shapes. Data has many uses. So, first thing you really need to do is to decide how do you want to use your data? What is the shape of your data? Also, in many cases, you will want to use multiple databases for the same data, but for different uses of that data. And I understand it's really theoretical, so I'll give you an example. For example, consider this. You need to build a system that tracks and stores information about package delivery system, delivering packages in mail, airmail, for example. So you have information: who is the client, who is sending the package, its properties, weight, size, how it is going physically from place to place. You have usually packages delivered by airplanes from city to city. So you have paths, you have information about clients. So I envision at least 4 databases that can be used to efficiently build this kind of system. First of all, we were talking about document database. It can store information about packages. Clients, it's ideal because package is something that very close to reality. If you model stuff very close to reality, package has properties, ideal for document database. Now you want to store and efficiently calculate how do you transfer them between cities, right? That's where your graph database comes. Graph database, you can search for shortest paths, you can search for inefficiencies, stuff like that. Then you can use for caching, for temporal storage, key value stores. They are ideal for that. So it's all about data, but not only. Now, when you have data, you usually ask questions about the data, right? Queries. So when you build very large system, and usually those kinds of systems are servers oriented with multiple services, here comes domain-driven design in place. So how do you plan, how do you query for things? Querying engine needs to have the least distance from the shape of data you're querying. For example, you should not query graph database for relationships because they are not designed for that. Many times people asked me that used SQL Server, why there are no joins in document databases? Very valid questions, right? We have documents, we want relations between them, but that's not how we model data with documents. That's a very different thing. You want relations as per joins, you use SQL Server. That depends on how do you use data. So, for example, querying for relations key value store database is, why would you do that? You have basically huge hash map or something similar to this. Next thing, I told you that data you can store in multiple places. There is very, very important that you need to decide single authoritative source of data, that you might store the same data in several databases, but querying, obviously you should query from single database. Reporting is also important. How do you do that? Because now that we have service-oriented architecture, multiple databases, you have several stores, reporting should be abstracted from the rest of the system. If you leak abstractions, all sorts of bugs and issues can arise. And when they do, it's not pretty. Usually what is usually done, it is abstracted as separate service, or at least it lays behind API abstraction of some sort. Now I have a question. We have services and stuff, so how do we connect it all? Because single database is nice, multiple databases need to have connections. That's where your principles of designing service-oriented architecture come. You will be doing domain events, the things that Dino were talking about, the events in your system, and in my opinion, event sourcing is excellent idea, and in large system, it simplifies lots of things. So you will be propagating via message buses or any other kind of buses, domain events, and building your services accordingly. So you store data and extract data for each type of database that you use in your system according to those events. This will make your architecture very scalable, and you'll be able to you will be able to afford flexibility, and that's important usually. Yeah, passing the message. Message bus technology is also important because you will want to use as abstract messages as possible. For example, I've seen systems that they were written in 3 languages, in .NET, in Java, and in C++. How did they do that? Simple. They used messaging protocols that can be read easily in each part of the system. Each vendor framework, you can see more specialized protocols than those that allow this kind of flexibility. In my experience, what really works is protocols that can be read and are multi-platform, cross-platform. Now it's time to ask some questions.
So here is the discussion part of our panel. If you have any questions and want to know something about it, or you disagree with something, you can ask our experts, please.
Michael, my name is Vladimir, and I would like to hear what is a basic concern or some good examples when we should look or choose document database.
Document database.
Yeah.
Usually document databases are made for what's called online transactional processing, and that means that document databases is all about what questions do you have, not what answers. That I like to differentiate between relational databases, document databases. Relational databases is about what answers do you have, and document database is about what questions do you have. If your system, if your design can tolerate some eventual consistency, and you will not find document database without eventual consistency of some sort. We discussed eventual consistency. That's one. Two, if your system has reasonably complex objects, that for example, normalizing of well-known 3-normal forms, it will be too hard, it will have overhead. If you have lots of relations between objects in your tables, if you have lots of tables, usually document database is a better choice. If you have a need for at least some sort of schemaless data, most of document databases allow schemaless data. Excellent choice. Have someone tried to talk with the DBA to add a column in production database? For example, document databases allow you flexibility that you will not have in relational databases. And if you require that, it's, in my opinion, a good choice. But I will not, I do not advise, for example, to use document database for analytics, for any kind of use that you need to have online queries that you need to have immediate answers, for example. Stuff like that. It depends. It's very hard to give specific rules of thumb because there are so many use cases that they should be discussed separately, I think.
And I think that I would like to take the challenge of providing to the question that you just asked a sort of a general rule. Okay, I agree with Micah. How do you say it? Right? Is it Mikhail or?
It's the same name.
Say it.
Mikhail is in Russian.
No, you in Russian are called Mikhail? Okay, Mikhail. The full name. Okay. Mikhail. I like it more. It sounds cool. Michael, it's American. Yeah, no? It's Michael. Yeah. Mikhail.
For English speakers, it's
It's
hard to pronounce Michael.
I would like to take the challenge, okay? I mean, I had Dennis here asking me to say Budiotu Lyotna, Budiotu Lotna, so I can say Mikhail. Okay. Anyway, I mean, I agree with what you said, that it's really hard to find a rule. But if a rule has to be found, I would like to put it down like, okay, you come from, I think 99% of the people come from a SQL Server or relational background. So keep on using relationals up until you get in trouble. At some point, you get in trouble because so Michael was absolutely fine saying it has to be fine and fair, saying it has to be seen. He listed a few scenarios in which it's known that document databases can offer some pluses that you don't find anywhere else. But it depends. So I would say, keep on doing things the way you have always done. If you find yourself in trouble, whatever kind of trouble, and typically it could be less than ideal performance, it could be, it's so hard to get the data I need, or it's so hard, it's a mess. The data model now, it's a real mess, and I really don't know how to organize data to retrieve quickly without losing myself in the web of inner joins, group by outer joins, or whatever. If you find in this kind of trouble, well, reconsider carefully the persistence layer and start learning new languages, persistence languages, becoming thus a polyglot persistence person. Another aspect that would be interesting to see the perspective of a document database person is personally. To reinforce my point, consider what was the trigger that brought NoSQL to become really, really popular. It was Facebook, essentially. The success of Facebook. Now, to see at which point you start getting in trouble with a relational model, think of Facebook. How would you imagine the mess it could be to create a relational data model for all the amounts of information and the rhythm at which the information is being served in Facebook? So when there is a stupid like, it involves the users, the Maltese 700 million users, the table with Facebook users. You have to read for that user, you have to find the list of posts of that user. And it's if you have a 700 million declared users in Facebook by the number of posts in the lifetime, so in maybe 5 or 6 years on average, that user has made, and then find all the comments on that post and find which one is being liked, and all the people you have to notify that someone else has liked the given comment on given user. Well, it's kind of problematic, okay? And more, imagine the indexes that are involved whenever stupid likes a fucking comment. All the index you have to rebuild, and how many likes are being made every second. So I'm speaking, how many people all over the world has liked some fucking comment on some fucking Facebook page? Well, I mean, it's just impossible to manage this complexity.
There is one another thing about Facebook. I really like this example. Very simple question. Think, how would you implement query to get friends of your friends if you have database of Facebook users. Friend of my friend.
Easy.
Impossible, right? That's where you decide you use graph database.
Exactly. So, and also another scenario is the use of a dictionary or what was the technical name? Hash maps or things like that to store information that looks like relational, but only verifies the first normal form of relationals. In a classic, so things like phone numbers of a person. So if you have a person which has its own ID and then one column for the phone number. But if you have a second phone number, you have to repeat the key of the customer, and that's not possible as is in that way in a classic relational table. You have to either add another column to make the primary key, or you have to do weird things, or you have to create a second table that contains the list of I have all the numbers, I want to run a fucking query. It's much easier sometimes to use a database table of another type that relaxes some of the strict constraints of the relational model, which are good as long as you really need them. Another point that I want to involve Mikhail on is, personally, even when I realize that at least some parts of my system are going to be better treated, better served by a NoSQL solution, I still consider that I have another level of problems with licenses and APIs, because Polyglot means that you have several engines, several APIs, some of which are only exposed via REST. I mean, that's not the case of CouchDB, that's not the case of...
CouchDB I think is REST, but MongoDB is not.
It's not, okay, no, but there are a few in which they don't I mean, I'm a .NET guy, so not always various elements in the NoSQL universe offer an easy-to-use, well-done .NET interface. And that's another issue for me to consider. So then I have to pay licenses with SQL Server and licenses to RavenDB, to MongoDB, whatever it is, to go in production. So this is also a point to consider. So you need to have a very strong reason for whatever you choose, but the point, at least my personal point out of this panel, is putting in your heads the idea that it's absolutely fine to investigating alternate ways of doing things if you find yourself in trouble, whatever kind of, even light trouble, with the model you have today, and expect these troubles to start manifesting more and more often if you try to build software to really match user expectations and how things are being done in the real world. Because some sort of social integration starts getting requested in any, or starts getting a plus, an interesting plus, an intriguing feature in all systems. Personally, I'm going to embark on the rewrite on a software that has been up and running successfully for 5 years. It's a booking system, and now we are going to consider integration to make it look like, similar to Facebook, in the sense that when you are going to book a court to play a football match with friends, and you have to indicate or select friends you want to play with, you can have favorites, you can have a blacklist. And this poses the problem of, at some point, of finding friends of friends. And at that point, even in a fundamentally simple system that today exists and thrives with one relational database and 10 tables. But even in such a simple situation, as you start adding features to keep up with the real world, at some point you may find yourself finding, well, probably I should consider adding some level of polyglot persistence to better treat and better implement certain features. Okay?
Greetings, my name is Pavel. First, I want to thank you both for for all what you did today. And I want to ask a question. You both mentioned RavenDB, and I never heard of it before. So what are pros and cons of it in comparison to MongoDB, for example?
I suggest we speak after this because I do not. I work on RavenDB. I'm core team developer for RavenDB. We can speak after this discussion panel about this. I will be happy to. So I think it's not. Yeah, yeah. It's not strictly relevant to Polyglot. It's relevant, but I don't want to make advertisements, forced advertisements. If someone wants to talk about RavenDB, I will be happy to, but I suggest we do this afterwards.
Okay, and then another question. Polyglot persistence makes backend a lot harder because we need to maintain multiple databases. So maybe it will not work as good as if we make small project, overhead for making data Polyglot.
Я понимаю, я
Да, окей. Только микрофон, ну хорошо. Что данные, они в бэкэнде, короче, будет много тогда баз данных, и с ними работать становится сложнее, да, из-за того, что их несколько. И в какой момент мы понимаем, что оверхед на поддержку этих данных, этих нескольких баз данных будет меньше, чем бонусы, которые мы получим за счет того, что будем работать с данными разных типов. То есть здесь у нас графы, здесь у нас там реляционные данные, здесь у нас там сырые данные MongoDB мы, короче, фигачим, и нам все это нужно поддерживать.
Okay, so Dino.
You want me to reply in Italian?
Yeah, of course. Dino, he asks about obviously doing polyglot persistence backend is an overhead and it's lots of work. So he says when the bonuses and the good things that come with polyglot persistence overweight the work that you need to implement this kind of persistence. I can answer at least at some part of this. First of all, things that require handling relationship in graph, you will not be able to implement otherwise. Yes, it's simpler to use one single type of persistence. Polyglot persistence usually is viable when you have huge project that you will be doing lots of work on backend in any case. And being pragmatic about how do you store data and maybe splitting it to several persistence layers or different persistence layers can make your job easier. Small projects, I don't think, I would not personally do small project with several databases. It's not needed. Polyglot persistence, as I think Dino rightly said, is for projects that run, first of all, into either performance problems or design problems, or they can use some performance enhancements so to get better user experience.
Yeah, actually, see, it was the same point that I raised. If I can go with one type of persistence engine, I will go for that. But personally, I would even ready to accept some extra work on my end, not to use multiple persistence engines if I can. So back to my example of the booking system, if I can find a way, when I look into the details, if I can find a way not to use a document database to keep track or whatever it is, to keep track of friends, I will be happy to do that. If that means that I will have to spend a lot more time in designing my own engine, I will probably do that. But at some point you have to choose, you have to scale to use different tools, more powerful tools to do the job. So it's really hard to answer in general. Your concerns are absolutely nice and fine. You also have to consider that probably if I don't know the details of most licenses because that's not my realm, but I understand that if you buy a license to SQL Server, I think for the most part, on one server machine, you can create 3 tables or 300 tables, it's always the same cost. If you jump to another engine, you have to pay licenses also on that project, on that engine, okay? And this is a cost. On the other hand, if you completely drop relationals and you jump on document databases, I mean, you save a lot of money in terms of licenses. And this is another aspect to consider as well. So it's really hard to find a simple rule, and probably the only simple rule is keep on doing things as you do today. The moment in which you run in trouble, stop and reconsider everything.
Vasily Fury, Double E's. So we use, in a recent project, we use two databases, Elasticsearch for search and something, and MySQL for storing data. And I want to discuss about why we using the relational databases. Maybe we use it because we know how to work with it and know what we do when, what to do when we have to change model, when we have to introduce new sub-entities. We can just change links and then aggregate new model in NoSQL storage, for instance. But what to do when we have only NoSQL storage, and how to change model when we have some terabytes of data, and what we should do? Can we just get rid of SQL?
Tough problem exists in the world. And the world is beautiful, it's such a beautiful place because there are so tough problems to address. I mean, I'm sorry for you. There's no easy answer. So, and everybody who claims they have answers, oh, you're no longer going to have this kind of problems if you do this or you do that, if you buy this or buy that, or choose this or choose that, is lying. It's lying because it's just showing you a small piece of the real world. It's just saying, I mean, it's not saying something false, but it's showing you only a small piece of the reality, of the real thing. So I think that if we can really find, again, just one thing that holds true regardless is be ready, be aware that there are tools that can be combined together effectively to work out a solution that works, but that has to be done on a per application, per context basis. And the perfect example of this is, once again, Facebook, but any other big social network out there. They were not built in one day, and I always smile when I hear, oh, we need to build a system, this has to be scalable. Scalability doesn't exist. Scalability is when you see, but over time, the number of users, the workload on the system to grow, and the problem becomes at some point you have to stop and try changing the existing architecture, rewriting the system, whatever, so that you can, in first place, consider the regular base of users, the critical number that you reached, and maybe at that point consider, okay, if the number grows, is there something I can do without modifying software? But when you face huge growth, which I wish everybody here, like Facebook, it's not easy. Oh, if only I had used Azure or Amazon or this or that. You stop and you say, okay, if I go to the cloud, I can have a certain number of benefits. If I use document databases, I can have other. But it's something that you consider when you have the problem, or where the problem is about to manifest. Not be, oh, I go to the cloud and I'm happy from, and I deliver the system today, and for the rest of my career, I go to the beach. Because I just fall, hey, Azure boy, please can you start up a bunch of new web roles, and I'm happy because I'm on the beach and I'm too busy relaxing to take care of that. It doesn't work this way. So the point of conferences, the point of training, the point of campaign, sales, even sales and advertising campaign of companies, it should be oriented to let people aware that there are tools that have some pros and cons, some specific characteristics that can be combined together. But, I mean, polyglot persistence at the moment is for the most part theory, in the sense that we have Facebook that provides a clear demonstration of how it works, but it's Facebook. Okay, it's Facebook. There are a few products that I know that use relational and some document databases. Sometimes it's Mongo, sometimes it's Raven. This is true, but beyond these two things, graph databases, it's theory. There are projects that use graph databases, but it's not common. Try filling with data a graph database. It's a nightmare. Yet, if that's the only fundamental way you have to optimize a certain data retrieval, you go through the trouble of filling data and then querying data.
I would like also to add some more notions about how do you select a database and how do you consider if a database is viable. I've seen people jump on new and shiny technology like it's something. I've even once talked with someone who works in a successful startup, and he said to me, I don't know what will be my next project, but I want to use this framework and this technology in this database. Why? So you should consider things like replication, transactions, concurrency in a database. You should consider if it's distributed or not. You should consider how durable it is, because not all NoSQL databases are really durable. What happens, for example, with database X if you pull out the plug? What happens? You should consider this. There are many more concerns that you should consider when you select database, but not only. For example, how can you monitor its performance? How can DevOps monitor if something happens? Do they have notifications, for example? How easy is the API? Does it even have bindings or API in the language or framework that you're using? How performant is the API? Amount of bugs the databases have. There are lots of very practical concerns that you should ask. You should not blindly jump on one or another database. For example, one of the reasons many people choose to use SQL servers because they have proven to be reliable when the server burns up or you pull out the plug, for example.
And again, if you're not in trouble with the current solution, stick to that and be ready to reconsider only when you see clear troubles, things that don't work or that you don't like. Because at the moment, like it or not, relational tables have been around for 40 years as a theory. Tools have been around for at least 20 years, Oracle, SQL Server, so they work. Now we are facing, and it's a few years already, some of us are facing challenges for which these tools are not completely ideal. Now, if you are one of these guys, you must, but for you, for your companies, for your employer, look into alternatives. It's your responsibility as an architect, but not for the next project I'm going to use RavenDB or Mongo or Cache. That's silly. That's silly. Unless your next project is a fun project, toy project. Yeah. If I want to write myself a website for my daughter to experiment with friends, blah, 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 okay, I have to persist data, I'll probably use RavenDB because I have my object, save the object, and that's it, works nice, beautifully. Using RavenDB to persist data is trivially easy. I used, for an article I wrote on MSDN magazine, RavenDB to encapsulate the identity mechanism of ASP.NET, so the username, information, blah, blah, blah. It was, surprisingly, considering that I used to use RavenDB, so not to use entity framework, I had to create from scratch a user store according to the base interfaces of ASP.NET identity. It was one line to read, one line to write, one line to update. It's trivially easy. Configuration is trivially easy. And I was reading and writing from a database. So the point is, the same thing can be done with entity framework, with relational. So, and if I already have that in place, or the people in my company, the IT department, for example, which then have the trouble of talking to customers, optimizing performances, doing fine-tuning, these kind of things. If these guys, these non-dev guys, today, for sure, they work much better, much more easily with existing tools because they have a career built on that and they are not so willing to change as developers sometimes are. And that's another point to consider. That's another point to consider. You have to retrain these people. You need to find out whether vendors of non-SQL Server or Oracle solutions, they have tools that are ad hoc for non-IT people. Because we know, Mongo, Raven, they have tools, but they are essentially developers' tools. Unless I'm missing some important pieces fixed. Yeah. So third-party companies like Redgate, but same JetBrains, have tools for, especially Redgate, for database performance monitor, which are used essentially also by IT people. So is this kind of support available for the platform I'm embarking on? So it's really silly. I want to use for the next project RavenDB or whatever it is, but not because of RavenDB or whatever it is, because it's silly, the approach. Unless it's a toy project and you wanna, it's a proof of concept.
Yeah.
More questions?
I think this is...
It's time.
It's time, yeah.
Okay.
This is a great thing, and we...
Thank you, everybody.
Thank you.